Everybody else, let's keep going. Steven, what are you going to talk to us about today?
It's going to be about converting C code to D.
Yeah.
Yeah.
So this sounds like it's going to be fun. Everybody ready?
All right. Before we...
There's no programmer energy. They're not ready. Also, there's no display. Should we fix that?
No, that's right. So before we start, I just want to show this informative video to everyone.
So Darren, how are things going at work? Charlie, I gotta tell you, it's just been so hard lately. I'm struggling because I have to just write so many libraries on my own. You're using D, right? Well, did you know that you can use C from D? And there are loads of C projects that can be used for every need. Wow, really? I had no idea. I bet it's really hard to use C libraries from D. Well, that's where you're wrong. C is super easy to call. You just declare a C function and use it. I can't believe this. I'm going to talk to my compiler right away and see if there's any C libraries I can use. Oh, I feel better already.
C is the original language of Unix and provides libraries for just about every task you can think of. Ask your compiler if C is right for you. C is not for everyone. Some people may experience the following side effects: segmentation faults, dangling pointers, buffer overflows, manual memory management, general feeling of memory corruption, zero-terminated string disorder, or an insatiable desire to smash your computer. On some systems, integer character sizes may be incompatible with D. Characters might be signed or unsigned. Declaring a function that doesn't match the parameters or return type may cause your program to crash at some point in the future in a totally unrelated spot. While using C, undefined behavior may occur, causing your program to explode your toaster or nuclear missiles to launch, depending on your job. If any of these occur, stop using C immediately and consult your compiler. C, helping you write better code since 1972.
I wonder if you guys recognize the studio I filmed that in. All right. So welcome to the clinic. So this is about my adventures of porting a large, I think this works here, large C library to D. Yeah, okay. So why are we here? This is kind of the story of how I did all these things face planted so many times so that you don't have to. I'll start off, this is kind of like an overview of how this is going to go. I'll start off with how I became involved in this project and the various stages I went through. Brief history, you may have seen my blog post a few years ago. D is a teaching language. I teach a homeschool class on coding. We first started out, there was kids that didn't have laptops, so I was like, well, what can we use just to get them started? And some of them had tablets or whatever, so I was like, okay, we can try JavaScript. We'll just do JavaScript in the tablets. And it was the most obvious choice as it runs everywhere, but there's not much you can do with JavaScript on a tablet. You're just basically manipulating web pages. It's not that great. So we went to Roblox. Roblox is a kind of a neat development system where it's got physics engines and 3D graphics and everything. So we went with that. Has Lua as the base, so you guys remember talk from last year. It's a nice base, but it's not really a lot of opportunity for regular learning. Like, you're just basically hooking pieces of Roblox to a little bit of custom code. And since it was something I'd never used before, I spent a lot of time dealing with the quirks of Roblox that I wasn't aware of. And of course, after that, we had to go to D. Kids without laptops now could borrow some for the class. I started small with some like text-based games like Hangman, but obviously the plan was to move to graphical games because that's what kids are interested in, right? So I found this library as I was asking them, what's a good like video games programming system in D? And somebody pointed me at this YouTube channel with, I'm not sure if I pronounced this right, but Kyril on YouTube. And it's a C library, but it has D bindings. And this is, if you want to visit this website, it's a really great introduction to doing video games programming with D. And I could get this up and running, like basically, aside from installing the compiler and MSVC and all the other things, we got it up and running in like one lesson. We could just actually make rudimentary drawings on the screen. So that was pretty good. By using raylib, I could focus on the overall design of the game development, like how things work, and not get held back by the complex systems. Like if we use Unity, it would be all involving a whole bunch. It was kind of like Roblox was like that. It's like we have to deal with all the intricacies of Roblox and not just worry about the code, whereas raylib is super simple. So there was the raylib-d binding. And this was included as part of the video series with Kyril. And it was provided by a GitHub user. And then he deleted his account. Like deleted the entire GitHub account. So I still needed it. But it's open source, so I resurrected it. And now I am the maintainer of raylib-d. And going on four revisions so far. And it's not that bad. Like with help from other users, I have a whole plan of how to build the next version. I could do it within a matter of minutes, maybe like a half hour, an hour. You just have these instructions, and these are the tools I use to do it. But first of all, this is just a bunch of examples of stuff from the class. Everything up here was pretty much either built in class together or by me, except for one. There's one that a student made. All right, so the first stage in our journey here is how do we do bindings? How do we bind from a D program to C code? D follows the C ABI of the platform of the system, which is really nice. You don't have to do any translation layers or FFI or any of that stuff. It requires that C code is built using the C compiler for the moment. A great tool that we use, and I've used it in, this is how I make the raylib-d binding, is dstep. Made by Jacob Karlberg, and it generates bindings automatically from C headers. This is kind of an example. If you have the following C code on the left here, which has some types and some pound defines and a function prototype, you get that on the right. All pretty straightforward, this is not like complicated stuff, but it's not perfect. It's a little bit messy. We have, of course, the C preprocessor. As you know, the C preprocessor can build whatever you want, and sometimes macros are part of the API. As Walter would say, it's non-hygienic. And there are some ways to replace macros with mixins or inline CTFE functions, but not everything is doable. However, most of the time for bindings, you just figure out the little bits that are different, and you fix those. So the instructions for creating raylib-d are in the generating.md file on my repository. We start with dstep with a specific command line to say, skip some of these things. Then there's a bunch of cleanup steps afterwards. And then we can test against known projects, right? So the most important thing about this is automation. We have to have automation because I don't have time every time Raylib comes out with a new version to go through and diff everything and make incremental changes or whatever. I just want to take what's there, go through my process. Maybe it's not all automated, but it's automated to the point where I don't have to do much, and I can go through the process without thinking. An example we had was, and Raylib is kind of explicitly stated he doesn't care about being backwards compatible. Like there was one function that was a rotate vector function, which changed the float argument from float degrees to float radians. Which was awful. I've created the new binding, let me run it against my thing, and it was like a ball bouncing game, and the ball's like going, Joop. It's like, what just happened? Oh yeah. So yeah, these are some of the reasons why we do this. Don't have time. C has no name mangling, so if you get something wrong, like parameters change, whatever, that thing we couldn't detect. But if like the number of parameters change or the types change, C doesn't help you. You know, if you link against the wrong thing, and it's just going to crash. So struct differences cannot be detected. I think this is the same thing for D anyways. Like D doesn't mangle the struct contents as part of the function, but you know, automation is just required because you're not going to deal with all these little nuances. Using continuous integration, which I would like to do in raylib-d, is a great way to fix this, because you just basically, once you've changed, your continuous integration builds and tests everything. You have some nice tests in there. So we've gotten that far. Now, this isn't something specifically I did. It was in the binding originally, but we don't want to use D to write C, right? C libraries are written in C, as we all know, but the D binding doesn't have to be, right? So let's compare these two things. This is an actual line from my pinball game that I was making. This is the actual line in my code at the bottom, right? Using operator overloads, looks pretty nice, right? This is how you would have to do it with the raylib functions, because C has no operator overloads. I much prefer that. And it's actually pretty easy. There's a mixin you just include in the structs, and it says, oh, I'm going to be able to multiply things together or add things together, and it's actually pretty easy to do. So we can add to that because, you know, even though we're binding to the C code, we can add functions to classes. We can add our own functions, whatever. We can add extra pieces on top of it that make things nicer. This is something I haven't done yet, but I'd like to. Enumerations in D are type. In C, they're always a constant. So it's just, you have an enum. You can even name the enum. It doesn't matter. Those are still global in the global namespace. So this is an example of an enum value from raylib. Notice the highlighted extra repetitive words there. But I would like to do like just keyboard dot comma, right? That's much better. And we can do this with D because we have introspection. So most of this is, but you don't have to write it all the time. You just have this one little thing tucked away somewhere, and then this is all you gotta do. Just mix in, make me a better enum, and there it is. So we can use introspection to make some cool things like that. Wrapping C abstractions. I don't have my presenter notes because I couldn't figure out how to get that, so let's see what's coming up next. Oh yeah, adding UFCS methods, I talked about that. Overloading, yes, overloading works. Strings. So C strings kind of suck. They're a pointer with a zero termination at the end, and D doesn't use that, and it makes it really hard to communicate back and forth without doing loads of extra allocations. We'll talk about that later. So I got to the point where I had this raylib-d library, and it's okay, but using C from D is still not great. There's so much cruft in C. C strings are horrendous to use in D. D has fantastic string manipulation, but then using with raylib is a pain because you have to convert to C strings. And then this is a list of all the ways you can draw a rectangle in C. With all the different functions, you have to match the name with the types. And I think we could just do that all in one overload. Just to talk about the string problem here, raylib has this function called text format. So text format is essentially sprintf. Does everyone know what sprintf is, right? What he's done, which is really nice actually, is because this library is targeted for kind of beginners, the thing you don't want to throw on top of beginners is manual memory management. That's like, you know, a difficult thing for beginners to deal with. So sprintf requires that you pass in a buffer. Well, you got to allocate that buffer somewhere in the stack, whatever. Text format doesn't require a buffer. because it stores a buffer as a static member of it, variable inside the function, and just sprintfs to that, and then returns that memory. Simple, it works, and then you don't have to think, like most of the time you're just saying draw text format, score is X%D, you know how that works. But with D, if I want to use my D tools to make strings, I'm going to get a string that's not zero-terminated. So now on top of that, to my kids, I was having to explain, well, you can use the D functions, but now you have to call this function called toStringZ. Don't ask me why you have to call it, you just do. Because these are kids who don't understand. I'm trying to avoid talking about pointers and all the other stuff that they have to deal with. But D is great for that because it has the GC, a lot of memory management is already taken care of. But, this kind of stinks. Now, wrapping is a possibility, but it has some drawbacks, namely allocation for no reason. So we kind of need to use C as a dependency is another problem. Even though in dub, you add raylib-d, it comes in as a dependency, fine. But you still have to somehow inject the pre-built raylib library as a link step. So it was kind of, every time someone wanted to start a new project, I have to remind them, okay, you got to go in the JSON file and add these lib commands just to get, and then also download the raylib library. And after a while, I decided, you know what? No, I'm going to put the pre-built raylib libraries into the repository, and I made an installation tool that now copies that library to your local directory. It's there. It's still, you still have to edit your dub file, which maybe I could automate that, but still, it's just, it irks me. So even with using all those tools, I can't anticipate all the issues, like, maybe somebody has a weird built raylib library. I don't know how that's going to work. Raylib actually has a lot of, and this is the thing that C libraries do, a lot of configuration options you can specify, like, oh, I want to include JPEGs. I don't want to include JPEGs. I want these other file formats, which are build time decisions that I don't know what's going to happen there. But the holy grail here, the thing we want is for dub, add raylib, and then you build your application. I don't want to have to download anything else. I just want this to work. So I created a new library called draylib. This is a really hard name to figure out. But anyways, the goal is to port all the C code to D. Kind of an ambitious goal. But I thought, you know what? I've always preached that, if you could practically compile C code as D, I'm going to practice what I preach. No more need for the C compiler or custom pre-built libraries. Great. I just add raylib and I'm done. Or draylib. 2 developers, I just have to give props to raylib-d, who is a member of our Discord and a frequent participant in DConf, who's helping me do this. And once fully ported, like right now we're just porting it, the API will be deified, meaning that I'm going to take out all the C crap and put D in there in its place. But we want the simplicity of raylib. So I really like raylib, the C library, because it's very easy to read and understand. The API is pretty simple. It just is missing some things like operator overloads, overloading, those kinds of things that just make the code read nicer. So yeah, how hard could that possibly be? So this is the first thing I did. Just take the C code, copy to a D file, and build it. What happens? Well, the first module I did was the core library, which contains all like the static state, does the event loop and all the things. As I went, I just basically would comment out a piece of code in our code.c, copied into the D file, and then compile, fix it, and then test against all the examples that raylib has a ton of examples. So I just start testing against the examples. Oh, it still works. And you can see from the screenshot, basically, I added this little D port thing so I can know, oh, it's actually using the D code. Then after that's done, do it again. Copy some more code. Test again. Fix the errors. the annoying little things. These are the parts that, and I have it listed at the bottom here. Watch Dennis's online talk. Dennis is going to come up a lot in this presentation. Watch the online talk that he made last year about his porting tool. Basically, simple things like null to null, arrow to dot, moving array indexes around, et cetera, et cetera. Those things just are tedious and annoying. But I did do them. At this time, I did do them. I was just like, okay, I'll just search and replace. Some of these things I search and replace. Some of them I have to like think about, and the array, order, how you declare arrays was not as easy to do that kind of stuff with, but wasn't too bad. We're still building using C code, so for the things that we aren't working on yet, that aren't our core.d, just use dstep to make bindings for that. So we're still linking like C code with D code. It's like a Frankenstein, ridiculous thing that we're making. Some small modules you can just port quickly, like a couple hundred lines, so I did that too. A large, complex dependency in raylib is glfw. Who knows what glfw is? Yeah, a lot of people. So it's actually completely included inside raylib. So raylib has an external directory. Like, this is one of the goals, right? He wants to be able to completely build without any kind of downloads or whatever. I want to control everything. Mostly all header-only libraries, and then this glfw. For now, we're just going to use the bind-bc binding and keep building with D. I'm glad that bind-bc works. In fact, I don't even use like a download. I use the library built inside raylib and just use the binding from bind-bc. And then I noticed there's a glfwd project, which is actually a port of all the C code of glfw to D. How did that happen? We'll get back to that. Okay, finally, our core.d fully ported. In my side time, like at beer confs and other things, several functions at a time, it took me from June to October, about 7,500 lines of code. My estimate about 40 to 80 hours, so like 125 lines of code an hour. Okay, that's not too bad, but it was working. Everything else is still C, remember, it's just our core. How much is left? So raylib itself still has more modules to do. We got our textures, 4,800 lines of code. Our text, 2,100 lines of code. Our models, 5,900 lines of code. And more. And then there's the external libraries I talked about. glfw. STB image, 8,000 lines of code. STB Vorbis, 5,500 lines of code. And no, this is not a typo. 70,000 lines of code in mini audio. Apparently audio is really complex.
Well named.
And there's more, right? That's not all of it. There's still more stuff in there. So it became very clear that manual porting is not going to cut it. So we did a side quest here. Maybe we'll leave stuff compiled. Maybe it doesn't all have to be D, right? There's no public API to these. Like there's no exposure of glfw or STB image to the raylib API. They're just internal details. They're implementation details. So maybe we can just keep compiling that with C code. That just has bindings, right? Maybe ImportC will work, right? I mean, this is something I tried recently. The latest DMD and LDC has it built in C compiler. Maybe we'll just compile those implementation details with ImportC, and we still won't need an external C compiler or have to worry about various odd discrepancies. But it doesn't work. I really do like the idea of ImportC, and I think if it can happen, if it can get to the point where we just say, I'm going to import this header file and it works, and everything is handled, it will be game-changing. I absolutely would use it for these things. But for right now, I'm not going to dig into whatever this is and try and fix my macOS library headers.
Oh, Steven,
Yes,
I need you to get those errors into Bugzilla.
I did.
Did? Okay, great.
In fact, we were talking at DConf, and you said, put them in Bugzilla, or try it, and if you find anything, put them in Bugzilla, and I did.
Because, you know,
I know.
Is the whole point of ImportC is to solve this problem you're having.
I think that is the goal, and I think that it's doable. But for now, I can't do it. I'm still working. So I'm resigned to the reality that I'm going to have to use pre-built C object files, or maybe invoke the C compiler from Dub. But Dub does a very poor job managing external artifacts, I think, still, right? There's no movement there yet. There must be something better. How did that glfd port happen? So now a miracle happens. I messaged Dennis and said, how did that happen? Did you just slog through it like I'm slogging through it, or did you do something else? And of course, yes, I have a tool that I haven't published yet. But here it is. And that was a miracle. It was, thank you, Dennis. Like, just amazing. So, now we're moving on to stage 4. Now that I realize I can do this, I need some more tools. Or I need to deal with ctod, make that tool work. So ctod is the tool that we're talking about. Again, watch Dennis's talk last year. Based on tree sitter, so it allows you to deal with not quite parsable code. Thank you, C preprocessor. Handles a lot of the minutia, like the null to null, the pointer, all that stuff. Maybe it's a solution to purporting these implementation details. Great, I could try it out. I did. Now, the first thing I did was my next project in the thing was rtextures.c. That requires stbimage.h and stbimagewrite.h. There's like a few files that are in there. ctod gets much of the way there, and during this process, I filed almost 30 issues and bugs against ctod, and Dennis fixed them probably usually in like 2 days, which was awesome. And now I have to run the process again. So imagine this, you run ctod, you start building it with the decompiler, and it's like, oh, fix this line, fix this line, fix this line. Okay, you go through like 30 lines. And then you get to a point where it's like, wait a minute, ctod did this wrong. Now I gotta get that bug fixed, and now I gotta start over. Right, I gotta go back to the C code, run the new tool on it, fix those 30 things again, and then get to the next spot. So the most important part of porting C code to D, you can guess, automation. We want to automate as much as possible, right? Just like the bindings, we want to automate as much as possible. Without automation, you'll never get there, right? You guys all remember Daniel Murphy's project to port the decompiler from C++ to D. Without automation, never would have happened. Also, ctod is not enough. Thank you, C preprocessor. So you can see something like this is inside raylib. This linkage thing is not it's not real code. What it is on Windows, if the isDynamic definition is defined, then we're going to define linkages, declspec, whatever that is, the MSVC thing for exporting DLL symbols. Otherwise, I forgot to include it in here. There should be an else, define it as nothing. And so it either gets replaced with a blank or that. This is what ctod does. I still have the linkage variable. And in fact, I think in a previous version of it, it would treat that as the type. So it would say linkage foo. And yeah, that didn't work well. And you also have this stuff at the top that isn't even useful. That's okay. that's the kind of stuff, it's like we can automate a lot of it and then just fix it up later. But I still need something to be more cognizant of the C preprocessor. So I thought, well, maybe I could just solve the macro problem by expanding the macros, right? Once this file is ported, I don't need to touch it again. It's an implementation detail, right? We don't care about versioning or code aesthetics. It could be as ugly as sin, and I'm not gonna look at it again. So I wanted to focus getting it working on one platform. So we'll just run the preprocessor that replaces macros. But the problem is that if you run the preprocessor on a file and it has imports, what's gonna happen? It's gonna pull all the files from all the places, paste it all together, and now you're left with this giant thing that is not usable as a ctod thing. Now Adam, is it Rupe? I don't know how you pronounce it, but Adam, everyone knows who Adam is, had this mention that GCC has the D switch for debugging. -D, capital I, keeps it does the macro expansion, but it keeps the existing macro definitions and includes. So ctod can still see them and substitute those for imports. And it also keeps the include statements. And then it also expands to macros, which is what I want. The -C switch keeps comments. I didn't realize this, but the C preprocessor strips all comments by default. We can't use that, right? We need all the comments in there. And it also outputs a whole bunch of garbage. #1, you'll see what it looks like. But using that output, if I write a tool, I can get the macro expansion we need and get back to the original code by removing the included files. But what about other compilers? Like, that's good for GCC, but what about Clang and MSVC? Clang does not have the -D option. MSVC does not. But they both have an option to keep the comments. And with comments, I can work with this. So introducing a new tool. The goal here is to just expand the macros. That's all I want to do. Step 1, detect all the pound directives and instrument them with these things. Why do we have 2? We have 2 because if that pound is like a pound else, then everything above that is going to be stripped out, or everything below it's going to be stripped out. So I need one of them to survive so I can recreate what was there. The number is to make sure that if I see both of them, then I can not output both of them. Because remember, when the C preprocessor runs, that pound-defined foo bar is going to be gone. All that be left with the comments. So let me show you how it works. Inside foo.h, I didn't actually include in this slide, is a pound define of bar for 6. Now, Walter will have nightmares of watching something like this because this is what the C preprocessor should never be used to do, but it is used to do these kinds of things. Instead of defining functions normally, we're going to use a begin and an end, and then we just put our code inside. Great. So what we're really looking to do is turn this, like ctod would never be able to handle this, but we were looking to turn this into the expanded thing that the preprocessor would do. First thing I do, put in some boilerplate stuff. Every pound you see just puts the thing in a comment, and then that's it.
Steven,
Yes.
the word for begin and end is no hire.
Exactly. So this is where we were. Oh, I didn't update this slide. But imagine that looks like this. But this is what it should be. It should still say the begin and end stuff here. But anyways, we run it through the preprocessor, and this is what comes out. This is all the garbage I was talking about. So each of these things are like directives to the compiler itself to tell it things about like where I am. If you have an error, it's going to tell you you've had this error in this header file. It's not really in the temporary file you've made here. Because we have the comment switch, we're keeping all the comments, which is essential because that's how I'm going to recover this. You see where it included foo here, But there's nothing there. And the reason why it's nothing there is because all foo had was a pound define in it. That's already gone. The pound define was bar is 6. So remember over here we said in x equals bar. Now it says in x equals 6. And if you imagine this begin, main, end, now it turns into that. This is real C code. I can use this. Finally, the second step is I take this garbage and run my tool in recover mode, which reads all those comments and turns it back into this. So this is still C code, but my CPP tool has basically got back to where I was, but with the macros expanded. That's all it does. Finally, we can run ctod on it. I can cut out that junk, the begin and end junk, which obviously doesn't mean anything. And I get my main file, so I'm good, right? So now...
Can you go back a bit on the previous slide?
What?
Can you go back a bit on the previous slide, please?
Yes.
So isn't fn supposed to be appended over there at enum string begin?
On this, in this thing here?
Yeah, yeah.
This is just what ctod interpreted that garbage as. It's not real code. Like this is the best it could do. Like when ctod.
Yeah, to answer that, I fixed that bug recently, and now it will add extra quotes to put contents of fn in that macro. But it's still garbage.
It did.
So,
This is actually the latest thing that you.
then it might be a bug report.
Yeah, that's okay. But I don't really care what happens here because I'm going to delete that. That was just, well, I still leave all the pound defines in there because I don't know which things are going to be important for, ctod, and I can just delete the things I don't want. So that thing I'm going to delete because it's useless. Anyways. So now we get to find out all the problems. Pound defines for things we expect. As you probably know, null is pound defined for 0. Seek end is pound defined for 2 or something. All these different things. So I got to put in a switch to keep those. There's also pound defines for things we didn't expect. Like, did you all know that sprintf is actually a pound define? I didn't know that. Then we add a way to skip those pound defines I don't want to replace. Basically, in the pre-processing, just prepend some stuff that I'm going to delete later. No problem. Then we fix the process and do it again. As always, automation is important. There are things that can't be automated. I'm going to kind of breeze through some of these last ones because I only got 5 minutes left. Implicit integer conversion. This is where ImportC would be great because I wouldn't have to deal with that at all. 0 as null. So even though null is pound defined as 0, and I said don't replace that, I'm going to leave that there. There is still code in like STB image that says pointer equals 0. I can't fix that. Initialization with C, you can initialize an entire struct with that. We have to change that to an init statement, like equals the type.init. Comma expressions. I'll show you that in a minute here. And yeah, D also has some annoying things. Like size of int times layers is, D is like, wait, that might be a 64-bit number. It's not. So I just have to tell it, no, that's actually, an int size of int. Those kinds of things you just have to fix up. This one, this is the comma expression. This is a line in the C code that when you expand the macro, becomes this. What the hell is this? This is a big nest of comma expression and what do you call those? The conditional expressions? The ternary expressions, yes. The way I figured out how to fix this is take the comma expressions and each individual comma expression make it a lambda, where each thing becomes a statement. Yeah, it's bad, but again, I never have to touch this again. Once it's done, I never have to touch it. The reason C does this, by the way, is so that you can have this nice looking thing and it can put statements into an expression. That's all those comma expressions are for. Thread local, This was a weird thing I had to deal with. Because this is static, so it's like private to the file, I could do this because the name doesn't matter. But because gshared is at the top of the file, I had to un-gshare the data. So I made a static inside of a structure and then alias that. That works. Variable shading, mostly easy to fix, just like most of its time, like iteration variables or something. Yeah, unreachable statements. Can we just get rid of unreachable statements as an error, please? The reason this is like this is because you could define std_cert to be nothing, and then it has like a fallback mechanism to do something afterwards. But of course, D complains about it, so I got to comment that out. But there's just so many places where this is like, if it's an unreachable statement, just don't generate code. It's fine. All right, I'm going to skip through this kind of. There's a lot of things that, yeah, there's a lot of things that are just difficult to deal with because there's just no analog in C, in D for this kind of stuff. Whether you're getting defined through a make file or from another file. Some other things that are not too important. It's kind of ugly, but who cares because it's implementation details. This is on one platform. If I had to do multiple platforms, I'd probably just run the tool on multiple platforms and then do diffs maybe. But yeah, ImportC would be great. Finally, it happened. I finished porting this and it worked. And it was quite a nice day when I was done with that. And if you subtract all the time of fixing C to D and building that other tool, probably I'd say like the final run through took me like 2 to 3 hours to port all those files, which is great. Like compare that to 80 hours or by hand. And then finally, the last thing for the future, I'm going to keep the C ABI, but yeah, first to go, C strings. We don't want those anymore. Better C right now is a requirement so that I can test against all the examples. We'll get rid of that. Maybe some memory safety in there. I did find a memory corruption problem when I first started doing this and had raylib fix it. You know, like I said, change the way the API works. Constructors, we don't have constructors in C. It'd be much easier to do some of this stuff. And then also I kind of froze on raylib 4.00. It's now 4.50. It was 4.20 as well. But basically some of the differences there. And maybe put a porting guide for people who use raylib-d. And that's it. I just did want to say something about this picture. So I took this picture earlier this month. I went to a corn maze in Vermont. If anyone doesn't want to hear the secrets of this corn maze, plug your ears. Inside the corn maze, they had all these letters that you could go by, and if you saw the letter again, you're going in a circle. And there was clues too. So this is the big clue, and I just want to zoom in on this because I think it's pretty apt. Once you pass the C, do not come back past it again. Thank you.
Did you consider libclang and/or DPP?
I didn't consider doing that. No.
Because libclang has this thing where it keeps all the macros, so you don't have to do any of those tricks. And DPP doesn't translate function bodies because it's not meant to do it. And
yeah, my first thing that I tried to do was use actually DMCPP. Is that what it's called? The C preprocessor that you have, Walter, digital marker. But I tried to just strip, just do the macros, but it was difficult to deal with.
Well, DPP does a lot of the stuff with the macros there.
Well, maybe use DPP instead of.
Well, it doesn't do the bodies, so that's the problem.
The trouble with DMPP, which is a C preprocessor, is it does a perfect job of implementing the C preprocessor specification. The problem is that most C compilers come with 400 to 500 predefined macros, most of which are unused and undocumented, and they appear and disappear based on what flags you pass to the C compiler, so it becomes basically an impossible job.
So just to mention that DMPP actually worked on STB image. Like it worked. But all I was trying to do is try and get like it's those little macros inside a file where it's like, I'm going to define this macro here and use it here, and that's it.
Yeah.
In two places. Those are the ones I want to expand. I don't want to expand the pound includes. I don't want to expand, null to 0. I just want to get those hairy bits done.
I really hate to say it, but I think you did far more work than is necessary with this.
Probably.
And the reason I say this is all those problems you listed are problems solved by ImportC. Now, yes, you did have a problem with ImportC. It spit out a bunch of error messages. Well, ImportC has gotten to the point where when you see those messages, it's because the header file is using some wacky C extension. And once you go look at the header file or the line where it is, it's some wacky C extension, which you probably do not even need in your code, and you can just comment it out. But other things like dealing with the null, the arrays, all that stuff, the integer conversion, it's all handled by ImportC, and you only have to fix it once. You can just fix the header file to comment out the junk that you don't need and won't compile.
That's the full automation answer, which I would love to have.
Yeah.
But then I have to stop working on this project.
Oh, yeah, okay.
Well, I wait for ImportC to come about.
Yeah, well, ImportC isn't perfect. Okay,
Yeah, it's coming.
I think it'll get you a lot closer than going back to manual conversion like this.
Yeah.
It's too much work.
Yeah, so I have a remark and a question. The remark is that I'm super disappointed it's called draylib instead of raylib.
You're super disappointed in raylib?
No, that it's called draylib instead of raylib, which was a much cooler name, I think. But no, more seriously, did you look at all the macro that the compiler includes automatically, when it's preprocessing? It does so, I think, to keep track of debug information. So have you tried to emit the same one because when you are adding comment, you're going to change lines and...
Yeah, but all I'm trying to do is port the code. So once it's ported, I want the line numbers from the new file, right? I don't want the line numbers from the header files.
Okay, yeah, fair enough.
Yeah.
Steve, thanks for the talk. I had a junior experience. I wanted to connect your comments with Walter's. I had a junior experience of yours. I didn't do something quite as ambitious. I was trying to get CUDA.h to give me automated bindings, right? And I ran into these same kind of errors. And I said, oh, crap. This is just, okay, here we go. And I spent 2.5 days doing the manual thing, trying to automate like you did. I had a much smaller task. But then I discovered it was actually due to exactly what Walter was saying. There's all this, you can't, well, maybe Walter can believe it, but you can't believe the amount of external state crap that happens with a CPU processor. My gosh, it's ridiculous. Yeah. Well, it's there. Anyway, the short story is I actually got back out, was able to get ImportC to swallow the whole thing and spit out stuff. There's one small addition that I had to deal with, but it's minor. And I wanted to say that before this experience, I had actually said this is a sinkhole, it's never going to converge, ImportC is a pipe dream, et cetera, et cetera. And now I think instead that there will be ongoing forever problems. I think that there will be forever things that don't actually converge. But it doesn't have to be that. It just has to be much, much better than the alternative, which I think you're revealing your pain. I think thanks for sharing that. But
yeah, this is the alternative.
I just wanted to say that I'm a lot more optimistic than I used to be about it. So I'm glad you presented this, and I'm also glad that Walter tied it in. It mirrored my experience exactly.
Yeah. Also, to be fair to Walter, when I started this project, like I said back in May or whatever of last year, ImportC wasn't even close to doing like preprocessor and stuff like that. So
I see all the work you put in, and I almost feel physical pain.
Well, so, some of it is I just wanted to figure out what is the experience of doing this kind of a thing. Can it be done? Is it possible to do? And I think it's actually still valuable because I've learned the pieces that need to be handled to get there. And I think ImportC could use that experience as well.
Yeah, two things. First, can we please stop making unreachable code an error? I think it's already not an error, it's actually a warning, but standard, the compiler treats warnings as an error.
Yep.
So you can just add -w.
Yes, it is just a warning, but in practice it becomes an error because dub turns warnings into errors by default.
By default, but you can switch it off.
What?
You can switch it off.
You can switch it off, yeah.
Okay. And the other thing is, as I understand it, ImportC, if you would use ImportC, you'd still have C strings, right? And you wanted the D strings.
I'm not going to use ImportC to,
Only for the internal
only for the internals, right?
Okay.
The raylib stuff, I'm not actually running my macro tool on. It's just ctod on that, because I want that to be as intact as possible. I just want the internals to be,
Understood.
And in fact, if ImportC gets to the point where I can run it, I think I could just swap it out. Sorry.
Yeah, we're done. That's all the time we got for questions. So,
all right.
Thank you. And now we'll have a quick 5-minute break.